This videotape deals with addition and subtraction of polynomials. It's basically a review. If you would like to see a more detailed treatment, I would suggest that you look at the appropriate tape in the elementary algebra sequence. Let's start with some definitions. Our first definition will be that of a term or a monomial. By a term or a monomial, I mean a product of constants and or variables. Let me give you some examples. X to the 8th y cubed is a monomial. It's a product of x 8 times and y 3 times. It's a product of variables. Okay, 4/5 x cubed y squared z. Once again, a product of constants, in this case, and variables. 4/5 is a constant, okay, and then we have x times x times x, y times y, and z. Okay, also something, a constant by itself, 5. Okay, this is also a monomial. You could think of it as 5 times 1, or 5 times x to the 0, because x to the 0 is 1. But still, it comes under the term. It can be described as a term or a monomial. Now, if you, in a term, you have a variable part and a constant part. Okay, the constant part, in this case 4/5, is the numerical coefficient of this term. Okay, and this is the variable part. Now, if you add up a specified number of these terms or monomials, you get what we call a polynomial. Let me write that down for you. A polynomial is a finite number, a finite sum of monomials or terms. You're going to add up a certain number of these terms or monomials, and what you get we will call a polynomial. Okay, now you can have a polynomial like this: 5x squared y cubed plus 3x squared y plus 4x plus 7. Here is a polynomial. It's formed by adding together 4 terms. You can also have polynomials that are in one variable only. Okay, for example, something like this: 4x cubed plus 5x squared plus 3x plus 2. Okay. The top one here is a polynomial in x and y. The bottom one here is a polynomial only in the variable x. Let's restrict ourselves for a moment only to polynomials in one variable only. In such a case, we define the degree of the polynomial. If we're talking about a polynomial in one variable, the degree of the polynomial is the highest power to which the variable is raised. So this polynomial here, it has degree 3. Okay, the variable is x. The highest power to which x is raised is 3. Okay, the degree of a polynomial in one variable is the highest power to which the variable is raised. As I mentioned, this polynomial up here has degree 3. I'm not going to define degree for polynomials in more than one variable, although I could. let's look at several polynomials. Minus 5x cubed, 4x squared minus 2x, x squared minus x plus 5. These are all examples of polynomials. And they're all in one variable, the variable x. The first polynomial consists of only one term. Such a polynomial is called a monomial. It's a polynomial with one term. Right? Because after all, a term or a monomial is a product of constants and or variables. If your polynomial consists of two terms, we call it a binomial. And three terms, a trinomial. This is one term. Here we add together two terms. Here we add together three terms. Now this monomial up here has degree 3. It's in one variable x, and the highest power to which x is raised is 3. The binomial has degree 2. The highest power to which x is raised is 2, and the trinomial also has degree 2. The coefficient of this term, the numerical coefficient of this term, is minus 5. This second polynomial, the binomial, has two terms. The coefficients are 4 and minus 2. And the three terms in the trinomial, coefficients are 1, minus 1, and 5. If you don't see anything right before the variable part, the 1 is implied. This is 1x squared minus 1x plus 5. The coefficients are 1, minus 1, and 5. Of course, we usually write it without the 1s present. Let's just take a look at terms. I want to discuss the variable and constant parts of a term. Let's look at a typical term, 3x squared y to the 4th. Okay, this will be the variable part of the term. This is the constant part, or the numerical coefficient of the term. If two terms have exactly the same variable part, we will call them like terms. Okay? So, for example, like terms, they have the same variable part. And as an example, okay, 3x squared y and 2x squared y are like terms. Okay, their variable parts are exactly the same, namely x squared y. By the way, if I had written this as, say, 2y x squared, okay, it would be the same as 2x squared y. And these would still be like terms. It's to help you to recognize like terms, it might be a good idea that within a term, say you put your numerical coefficient first, your constant first, and then you arrange your variables, say, in alphabetical order, so that when you have two terms like this, you'll rewrite the 2yx squared as 2x squared y, and then you can see that these are really like terms. Okay? In this form, they don't look too similar. And here, of course, you see that they are like terms. So within a term, you might want to use alphabetical order on your variables. Now, when you're dealing with like terms, you can often simplify algebraic expressions by combining the like terms. Let me give you an example. Say you want to add 5x and 4x. You'll notice that these are like terms. The variable parts are the same. What we can do is factor out an x, like so, using the distributive law. A plus b times c is ac plus bc. This is 5x plus 4x. So this is certainly equivalent to that by the distributive law. And 5 plus 4, of course, is 9. And we see that 5x plus 4x, they add together, give us 9x. Very often, of course, we leave out the middle step. Okay, this is done in your head. And what you do is if you want to, say, add like terms, you combine the numerical coefficients, like so. So 5x plus 4x. First thing you do is you make sure you're talking about like terms. And then you can add the 5 and the 4 to get 9x. OK, let's try another example. 3x squared y minus 8x squared y minus 4x squared y. These are all like terms. They all have the same variable part, namely x squared y. OK, let's put in that extra middle step just for this example. 3 minus 8 minus 4x squared y. 3 and minus 8, that gives us minus 5, and minus 4 minus 9 x squared y. Of course, you could do that in your head. Minus 9x squared y. So let's try another example. 3x cubed minus 4x squared minus 6xy minus 3x squared minus x cubed plus 6xy. We would like to simplify this algebraic expression. OK, now, first thing you notice is that all of the terms are not like terms. OK, this one has an x squared, this one has an x cubed, this one has an xy. But some of the terms are similar to each other. Well, this term and this term, these are like terms. You have a 3x cubed and a minus x cubed. You have a minus 4x squared and a minus 3x squared, a minus 6xy and a plus 6xy. Let's rewrite this. OK, we can rearrange the order. The terms are written in. Let's rewrite this where the like terms are next to each other. So 3x cubed minus x cubed minus 4x squared minus 3x squared minus 6xy plus 6xy. All I've done is rewrite this. The 3x cubed and then the minus x cubed. The minus 4x squared and the minus 3x squared, and then the minus 6xy and the plus 6xy. Of course, it wouldn't matter which terms I wrote first. You could write the x squared terms first, then the x cubed terms. Of course, your answer will look a little different, but it'll be equivalent. OK, now the 3x cubed minus 1x cubed gives you the 2x cubed. Minus 4x squared minus 3x squared, that gives you minus 7x squared. Minus 6xy plus 6xy gives you 0xy, where the xy term drops out. And this is your final answer. As I mentioned, you could have gotten also minus 7x squared plus 2x cubed if you had put the x squared terms down first when you rewrote it. Let's try a slightly more complicated example. 3 times 4x minus 5y. Take away 2 times 3x minus 4y. Before we can add like terms, to simplify, we first have to use the distributive law. The 3 is going to have to be distributed through the parentheses, and also the minus 2. OK, so first we're going to multiply this out, and then we'll look for like terms. 3 times the 4x gives us 12x. 3 times the minus 5y gives us minus 15y. Minus 2 times the 3x gives us minus 6x. Minus 2 times the minus 4y gives us plus 8y. You could also think of, say, distributing the 2 and then subtracting. But this seems to work. This seems to be a little easier. We just take the minus 2 and distribute that. It's perfectly OK. And remember, when you have to distribute it all the way through the parentheses. It's 3 times the 4x. Most people remember that. The one they forget is the 3 times the minus 5y. OK, now let's look at the like terms. We have the 12x minus 6x, the minus 15y plus 8y. 12x minus 6x gives us 6x, minus 5y plus 8y minus 7y. And minus 7y plus 6x would also be an acceptable answer in this case if you had written the y's first. Okay, let's try another example. 4x squared y minus 6xy squared. Take away 2xy squared minus 5x squared y. For some reason, people have more trouble with this, which is like a straight subtraction. This polynomial is being subtracted from this, than they have with this one over here. You see, in this example, they understand that the minus 2 has to be distributed through the parentheses. Here, they sort of get confused. It might be helpful for you to realize that there's really a minus 1 in here. The minus really means minus 1. And the minus 1 is to be sent through the parentheses. Okay, so we have 4x squared y minus 6xy squared. Now, minus 1 times the 2xy squared, that's minus 2xy squared. Minus 1 times the minus 5x squared y is plus 5x squared y. Okay, by the way, if you had not put the 1 in, and you thought of this as subtraction, you'll see what happens here. When you subtract, you change the sign to addition. Well, instead of subtracting, you add the opposite. And that's exactly what we're doing here. Instead of subtracting this, we're adding. And notice we have the opposite of what's in the parentheses. That is, every term has its sign reversed. For the plus 2xy squared, we have minus 2xy squared. For the minus 5x squared y, we have plus 5x squared y. So you can either think of sending the minus 1 through the parentheses, or to subtract, you're going to reverse the sign of each term in the parentheses and then add. Either way. I think it might be a little easier to actually put that minus 1 in and work it out like that. Okay, now let's look for the like terms. We have the 4x squared y and the 5x squared y. You have to look carefully, okay, because you can sort of be deceived if you look very quickly. It's the first term and the last term that are the like terms. 4x squared y plus 5x squared y. And now minus 6xy squared minus 2xy squared. If you want to skip this step, it's okay, but I think there's a lot to be gained. If you write it down, you can really make sure that the terms are the like terms. They may look it, but when you look at it right next to each other, you may see that you made a mistake. 4x squared y and 5x squared y, these are like terms. That gives you 9x squared y. Minus 6xy squared minus 2xy squared gives you minus 8xy squared. Okay, let's try another example. 8x minus 4 times our bracket, 2x minus 3 in parentheses, x plus 2. We want to simplify this algebraic expression. Okay. Now, you can start by distributing the minus 4 through the brackets. However, I think in a more complicated problem like this, it might be a good idea to work from the inside out and try to simplify what's inside the brackets first. Okay, it's not the only way of doing it. You could distribute the minus 4. Okay, it's a little easier here if we work from the inside within the brackets, simplify what's in the brackets, and then worry about the minus 4. Okay, 8x minus 4 times. Now let's simplify what we have in the brackets. We have 2x. Now the minus 3 is to be distributed through the parentheses, giving us minus 3x minus 6. Remember, by the way, there's no ambiguity here. We're not talking about 2x minus 3 times x plus 2 in parentheses like that. Okay? According to order of operations, first this multiplication will be performed. Okay, and then you'll be adding the 2x. Now, within the brackets, 2x minus 3x, those are like terms we can simplify, giving us minus 1x minus 6. Now, we will distribute the minus 4 through the parentheses. Minus 4 times minus x, that's plus 4x. Minus 4 times minus 6 is plus 24. And once again, combining like terms, 8x and 4x gives us 12x plus 24. And there's our answer, and this brings us to the end of the tape.